So what's the difference between balls and toruses? Tori? Toruses. What is the difference? What is the difference? And I'll tell ya. It has to do with what we were talking about before, links and caps. So in graph theory, we learn about paths and cycles. A path is one of these things. And a cycle would go all the way around. And then, so what's the Euler characteristic of this? 1, because you have one more points than you have. There's a beep, that was weird. Okay, you have one more points than you do edges. One more vertices than you do edges. And then here, number of edges equals the number of vertices because you went back around. This gets us to what, yeah, freaking screensaver. This gets us to what we were talking about before. This would be puzzle piece or link, and another link, and then stick a cap on it. Or, cap over here. Whatever you feel like. Because you just need one more vertex. So these are these. One vertex minus one edge is 0. So a link like this particular link has a number of 0. And this extra cap is just 1 point, so it's 1. So 0 plus 0 plus 0 plus 1 is 1. What is the cycle? Well, it's only links. There are no caps. Which is why a cycle should have 0. And once again, what's the next step? What is the next step? What's more dimensions? Well, that gets us to our little torus we were talking about. So I'm going to create a 3-dimensional link. I'm going to draw it like this to emphasize that it's dash. It's like a little tunnel. It's a tunnel. Yeah, you can kind of see. These lines here are dashed. So these lines and these points here, they don't exist. And then I'm making it hollow, so we could put them all together, because it's a hollow thing, because otherwise you need to count this stuff on the inside, and I don't want to do that. So, what's this thing's Euler characteristic? 0. Why? Well, I have 1, 2, 3, 4 points, and then 1, 2, 3, 4 faces, and then double that many edges. 1, 2, 3, 4, 1, 2, 3, 4, 8. So 4 minus 8 plus 4 is 0. So how would I make one of those ball things that could go into a ball? That we said has an Euler characteristic of 2 all the times. I haven't proved that it all the times has that, but it'll become evident niche. And I'm sure that someone else has proved it. I might should go and prove it. But right. I mean, I'm not doing a whole lot of proofs, but I'm doing more examples and finding patterns, because you kind of have to find the pattern before you prove things. I should have left that up. Darn. Okay, I'll draw it like that. So, what is ball thing? Well, I've, let's put a couple links there. So, what are the caps? Well, since this is just a long tunnel, I need a cap for this end and a cap for this end. This one should be just the face, because these edges are already existing. So this should be just the face. This side how do we cap that off? By a face bounded by vertices and edges. This, 0 points minus 0 edges plus 1 face, 1. 4 points minus 4 edges plus 1 face, 1. And these we decided were 0. And this would work for links of different, not dimension, but I want to say, so it could be like a triangle-y thing. Bunch of those put together, and then the faces would be just a triangle-shaped face and a triangle face bounded by edges and vertices. So, and it's only the caps that matter, because you can have as many links as you want, and they're all 0.